Okay, today is May 15th, 2018, and right now at 10 p.m. we have a temperature of 55 degrees here in the foothills of Los Angeles. The relative humidity is 72%. The dew point is 46 degrees, and we have a barometric pressure of 30.01 inches. All right, so now back on May 11th, 12th, and 13th, the area received some rain. Depending on where you were in the foothill communities, you received between a quarter and a half inch of rain, and that fell over 3 days' time, generally in a light rain slash drizzle. And so that's good. Since that time, since the 13th, we've had elevated humidity, and the ground remains damp. And as I say, it's humidity right now is 72%. The next thing I want to say is that I put a video on a new video on the playlist, which is a video by Mel Strong, and it is a video of cumulonimbus development. And I'd like everybody to see that video and pay particular attention to some time points in the video, particularly at 8 seconds, and then at 16 to 25 seconds, and towards the end at 50 to 57 seconds on the right hand side, and precisely at 52 seconds on the right side. You'll see where the microwave transmitter is actually targeting the roof of that cumulonimbus development, and how at the 8 to 10 second level, or rather the time 8 to 10 seconds on the counter, the video counter, the time counter, you'll see that the back portion of that development begins to collapse and implode. All right, so these times that I've listed, the 8-second point, and then we have 16 to 25 seconds, there's a massive implosion of the development of that weather system. That system should have dumped a lot of rain, but as you will see in the video, at various points, and you should watch that on a big screen monitor, by the way, if you can, because you'll see the little rings that are generated by the superheating process at the top of those, at the very top of the development. And particularly at 52 seconds over on the far right side, you'll see some very interesting detail. And once again, that's in the playlist, in my playlist on the One Pacific Redwood channel. All right, so right now we're looking at the northeast Pacific water vapor loop. We can see a gale force system right here. Earlier today, this was moving due east. That has changed direction slightly. It's now moving slightly to the east-northeast. We can put the grid on here. This is a giant system, a surface to upper level low pressure system. We'll take a look at the charts. I believe this is a closed low at the surface, and also all the way up to the 300 millibar level. Over here we have a low pressure system, and right here we have a low pressure system right over Nevada, which is spinning a lot of moisture counterclockwise around that low. This is being manipulated. We'll take a look at that. We can see the size of this gale force system out here. This is a 1,000 millibar system. It's being worked on. We can see the straight edges there, and the vortex. There's actually a right angle right there, and also there's a right angle right up here. Now I took a look at the Alaska map, but this area right here was not visible. It was just out of view. The Alaska map covers just sort of the very edge of this eastbound frontal system, which is actually part of the jet stream. We can see that there, this high-speed flow. And notice the evaporation here. Some of this moisture is attracted to that low pressure vortex, and it's all being evaporated by this transmitter, which is maintaining a separation between this next system and this gale force system. And we see the same thing happening between this system and this low pressure right over here, which is really not even listed. This is being squashed we do see that that is a counterclockwise rotating vortex moving towards Central California. And we have a transmitter right here generating a separation, an electronic wall, which is going to prevent these two from merging. And also we have a low right here, and that is appearing to merge with that low right there. So let's go ahead and take a look at the next map. We can see here in the western U.S. water vapor loop what's happening. This water vapor here is wrapping around. This little area of low pressure is being worked on and destroyed, squashed. We can see a lot of disorganization here around that little area of low pressure. You can see a hole open up towards the end of this loop right here as that descending air is forced into that developing low pressure vortex. And of course this low out here has been almost completely squashed. There's no organization whatsoever in this low, except you might say there's a little bit of counterclockwise rotation here in the water vapor map, but looking at the IR map, there's not much water vapor that's organized. Over here we have some rain. If we take a look at the Doppler map, we can see that the western U.S., we can see where that precipitation is falling right here in Nevada and Idaho. Okay, so we have another opportunity for rain right here. That's being squashed. And then we have this gigantic gale force system here, which is moving. Earlier today, this was moving due east. And right here we can see that right angle right there. Look at that right angle right there. That is a satellite transmitter that is heating the vortex of this weather system. That is either a phased array microwave transmitter or a laser. And what happens is that the heat generated by this transmitter eventually separates the associated frontal system from the low pressure vortex. And we can see that a lot of this moisture here is not wrapping back around into that vortex. Let's go ahead and take a look at this map once again. We can see that the whole left, the entire left half of this low is basically missing. This should be a giant spiral, uniformly distributed. The water vapor is not uniformly distributed around the vortex. As you can see, there's only basically a half of a weather system there. The other half has been evaporated by the transmitter activity over on this side. And that's why we're seeing all this evaporation from the frontal system from this system. It's moving towards the low pressure. Higher pressure flows to lower pressure. There's the low right there. So there you see it. None of this is going to be shown on the nightly news because that would upset the narrative, the climate change narrative, the carbon dioxide, preposterous carbon dioxide narrative. It's being peddled by the mainstream media. Here we see here in the west central, I believe this is the west central infrared map. See what's happening to this low right here. It's being squashed. We can see the center open up. That will prevent any counterclockwise development there. And we see all the evaporation. So there it is. Here's the surface analysis map. We can see that low pressure system right out in the Central Pacific right here. This is that 1,000 millibar low. This was moving due east. Today it's or tonight it's moving sort of to the northeast. We've got a low right off California, which is not really listed. It's just sort of squashed out. It's been completely squashed. Nothing left of it. Here we have the East Coast. Let's see if we can get this map to work. Well, okay. Let's try to work this manually. So there is a disturbance indicated on the National Hurricane Center map right down here in the northeast Gulf of Mexico. And I'm just sort of scrolling through this. We can see some counterclockwise development right down here, and we see a sort of a right angle right there, right over the panhandle of Florida, right here. And that is a transmitter at work, attempting to prevent that area of low pressure from developing. Okay, so that's pretty obvious. We have two straight edges right there. I hope you can see that right here. All right. Now if I run this in the auto mode, okay, there we go. This is a temperamental map. It doesn't work all the time. See some thunderstorm development right here over Texas. If you take a look at the telecast Doppler, we can see that development right here near the Oklahoma border of Texas right here. Next, we have the pressure maps. In the background, you'll see South America. That's a mistake. But this is generally what the Eastern Pacific looks like, the Central and Eastern Pacific. And we have the U.S. over here. We've got this. This is the surface level map. We can see that closed low. This is that gale force system. We've got the high pressure separating that system from the two lows over in this area, right off the California coast. If you go to the 500 millibar map, we can see this is also a closed low. We have low pressure right here indicated at the 500 millibar. That's 18,000 feet. And then at the 30,000 foot level, the 300 millibar, we can see the lows indicated here and this gigantic low out here. So we should be getting some rain if this continues to move to the east. This should bring some cool weather and some rain. But we just don't know what these people controlling our weather will give us. We did receive some rain the other day, which is good. But Southern California has been robbed continuously, and we'll keep an eye on things, and we'll do another update here real soon, and we'll just leave it right here, and take a look at this right angle up here. That is not CO2, or that is not caused by smokestack emissions, and this will not be shown on the national or the nightly news. Okay, that's it.